Welcome! In this project we are going to be making an imaginary highway advertising board. Now I believe in Australia that having advertising boards that are electronic and scroll across the screen is actually illegal because they distract drivers, but in our imaginary world we can have a little bit of fun with it. And going on that theme of having a bit of fun, I'm going to create some advertising slogans for an imaginary high school that I think are kind of funny as well. So if I click Start Simulation, it'll cycle through here some different advertising slogans. Swan Pond High School, not as bad as you might think. And once it's finished that one, it's going to go through with its second one, which is Swan Pond High School. Don't believe everything on the news. Okay. So basically your one, it'll keep cycling through some of these different ones. Your one does not have to be about this at all. You can make this a sign that is saying anything on the road. It could be some funny road safety campaign. It could be some funny or serious advertising for a particular product. But imagine that this sign was very, very large up on the side of a highway or something like that, and be creative. So let's get started. For this project, we'll be using an online environment called Tinkercad. If you Google Tinkercad, it is the first result here. Now you should be able to sign up or sign in with your Google account. Once you've done that, if you click on Create and Circuit, because Tinkercad also lets you do other things which we won't be doing, you will go to this view here. Now, just a brief introduction, we have this workspace on the left, and on the right hand side we have all of these electronic devices. We will be primarily using the Arduino, which is a small microcontroller chip on a computer board that can be used to write computer programs that control electronic devices. You can also drag on other things that you might need for your project, such as lights, resistors, and switches, etc. And you can, by left-clicking, wire up different components and connect them into electric circuits. You can also write code for the chip on the Arduino by clicking on the code button here. We will be using the text rather than the blocks, and the code will be written in a language called C++, which is fantastic for running very, very fast on low-powered, inexpensive chips like the Arduino. Your project should auto-save without you having to do anything. And if you want to change the name for what your saved file is, you can do so up here. So there is a link on the website to a template that has the hardware set up for you. Obviously, later on, if you would like to try and make this for real with a kit, you can do that yourself, or you'll have to do that yourself. I can't give you a digital template of that. But for the moment, I want to take the focus off the electronics a little bit and more onto the programming. If you're doing STEM, the focus tends to be much more on the electronics and less on the programming, and I'd like to be the other way around here. But like I said, if you'd like to physically make this later, you can, or if you'd like to copy it and recreate it yourself, you can. But if you'd like to use the template, just click Copy and Tinker. Once you've followed the link, you'll need to sign into Tinkercad with the class link first. If you have any trouble, let me know. So if I click Copy and Tinker here, it will create a version, hopefully. Okay, here we go. And you can see if we click on the code, then there is not very much in here. I don't know how big I can get with the code. When we're actually coding, I'll make it as big as I can. But there's not much in there, so it doesn't do anything. But all of the electronics are in place. Now, like I said, in this course, I don't necessarily need you to understand every little detail of how the electronics are connected, but I will just go over the basics so you have a rough idea, okay? So first of all, we have 5 volts of power going in here, and also a ground to make a circuit. Otherwise, no electricity will go through, as you probably know if you don't have a circuit. And those run through a potentiometer here. Oops, I don't want to move that. That once you start the simulation, you can actually move the potentiometer. And the reason we have this potentiometer is it actually adjusts the screen brightness, and you'll find a sweet spot that works, that you can see perfectly. But if you move it too far, then it won't be bright enough. It'll be too bright, and you don't see the letters. You just see blocks on the screen. So have a play around with that. It should be set to the correct position for the moment. Bear in mind that if you make this in real life, the potentiometer looks a little bit different. It's a turny, big vertical thing. You'll find it. Otherwise, I'll give you a hand. We also have a lot of these green wires here are not to provide electricity, they're to provide data. They're to provide the letters that will go through onto this screen here. And it's very important that we connect the correct ones up. Well, actually, it isn't. In the code, it's very important that we make the code, in the code we tell the Arduino which ones are connected to which thing. Now I've left 0 and 1 because they also have other functions we don't want to get in the way with the serial port, but I've got 2, 3, 4, 5, 6, 7 all connected to this point, this point, this point, this point, and this point, and those are the specified data points. Now, when we start writing the code, we aren't going to have to do all the complex coding to make it display certain letters and things. We're actually going to use what we call a library, which is a set of pre-made code that'll do some of the behind-the-scenes stuff for us. We are going to try and just get something on the screen. Maybe we'll just do the classic Hello World program, which is usually the first program you do to check if something is working. It's a bit of a tradition. Or we might put some other message on there, up to you. So basically, like I said, we're not going to be doing all of the coding under the hood ourselves in this one, like we did on some of the previous projects. We're going to be using a library. So a library is basically, it's a whole block of code or unit of code that somebody else has written, and we can use the functions that they've created. And so people have written libraries to use the LCD screen here, and we need to import that library up the top. So the way that we would do that up here, and I might just make this as big as I can, even if it's a bit ridiculous on your screen, is we say hashtag include, and then we have these little triangular brackets, and we say liquid crystal.h, and the Arduino, that's built into the Arduino software here that we're using, Tinkercad, but also the web-based Arduino one as well will have that library built in, hopefully, and we can use some of its functions. So we're going to go down here, and normally if we wanted to create a variable, we would say, for example, int score equals 0, and that means we're going to create a variable called score that we came up with this name, and it's of type int, integer. Now this library has a new type, which isn't an integer, it's a liquid crystal. So we're creating a new liquid crystal. Now that stands for the LCD liquid crystal display that we've attached. So we're creating a new liquid crystal, and then we need a name for it. I'm just going to call mine LCD, but you could call yours display, for example, but I'm just going to call mine LCD. So just to be clear, this is the name of it, and this is the type of thing we're creating. Now we have to tell it the pins that we have connected up to various parts. Now you can look this up to get it correct on the internet, but again, I'm not so worried about it. I've made sure that this works, so the numbers of the ports in order that we've connected up are 6, 7, 2, 3, 4, 5. And again, in the documentation it says, oh, you need to say first the one that connects to this port and then the one that connects to this port. Like I said, I've done that for you. Don't worry too much. Make sure you get it correct, otherwise you might get some really, really weird results. Okay. Now we have a little bit more setup to do. Remember this setup function that doesn't return anything, it's a void function. This setup function runs once at the start of the program, and we want to tell the LCD to begin. That's lcd.begin. And the 16.1 refers to the number of columns that we're using and the number of rows. So if you go down here, this particular liquid crystal display, oops, I will have to get smaller, I think. This particular liquid crystal display has 16 columns, and we'll be using all of them. And it has 2 rows, but we will only be using 1, okay? Because we want to scroll across the display. You might like to play around with that a little bit differently in the making it your own portion of this project, but it's completely up to you. Okay, so the next thing that we're going to do is, once we've begun, is we're going to go down into this loop. Now remember, this loop runs over and over and over again. You can delay the loop, for example. You can do something and then type in delay 300 milliseconds, which is almost a third of a second. That would be roughly a third of a second there. So you can delay and it'll do everything in the loop in order, and then it'll go back to the top of the loop and run through it again. So let's just get something. Actually, if we want to just get something displayed on the screen and not have it scroll or anything like that, we can probably just display it at the start of the program. So maybe we will do that. Let's say lcd.clear the screen, just in case. You never know what's happened. And then we'll say lcd.print hello world. And hopefully, fingers crossed, when I start the simulation, it says there, hello world, and we have something on the screen. Now, again, you could do something like delay for 1 second, which would be 1000, and then you could say lcd.clear and lcd.print now go away. And we'll see if that works. I'm going to have to put another delay at the end, because otherwise it'll loop back up to the start. Oh, no, actually, no, we're not in loop, so I don't need to. My bad, sorry. This only runs once, this setup function. Oops, what did I forget? Have a quick look. I can see it. Have a quick look and see if you can work it out. Maybe pause the video. Okay, so hopefully you worked it out. I forgot the semicolon there. I might need to refresh the page because sometimes it gets stuck like that. So I will put the semicolon on the end. Tells C++ or C languages, C-based languages, that is the end of the line. And if we forget it, it gets very confused. So we'll start that again. It says hello world, now go away. Okay, so have a bit of a play around with that. Have a play around with printing stuff on the screen. Maybe you could put things in loop and have them loop around. Don't forget to put a delay each time. We are going to get into displaying a message that scrolls across the screen, and hopefully you have thought about what type of message you would like to display on your advertising billboard. You can make something funny or ridiculous. Probably not something, truly horrific, but something that's a joke is perfectly okay. And we're going to start moving some stuff from the setup here to the loop, because we want this to keep scrolling over and over again along as we go. So the first thing I'm going to do is I'm going to take all of this code here. Oops. Say Control C. Oh, sorry, I need to stop the simulation. That's why that's not working. And this lcd.clear at the start probably isn't going to do anything on the first loop through, but when we start subsequent loops, it'll be good to clear the screen before we keep going. And it doesn't really hurt if the screen's already clear to clear it again. That's perfectly fine. So that'll clear everything on the screen and hopefully move things back to the start up there. Okay. So we've got lcd.clear. Then we've got lcd.print hello world. Okay, so I'm going to change that to one of my sayings. Now, I might just change it to, this is a really funny message, but please make yours an actually funny message. Be creative. And let's just see if that works. So if I hit start simulation, okay, this is actually really interesting. You can see it's kind of flickering here. And the reason why is because it keeps clearing and printing this as rapidly as it can. If we want that to stay on the screen for some length of time, we probably need to put a delay. So if I say delay maybe 2 seconds, 2000 milliseconds, now we'll only get that flicker every 2 seconds or so. There we go. Okay. Now, let's try and get it so that it scrolls from right to left. Yours can scroll the other way if you want, but that's kind of really distracting because it's not the normal way that things happen. But hey, maybe you're trying to get those drivers' attention. Instead of having them look at the road and the cars in front of them, you really want them to look at your sign. So, but I'm going to do it left to right, sorry, right to left. Scroll the display left. Let's call it that. So what I'm going to do is I'm going to paste in this command here that says lcd.scrollDisplayLeft, and this is actually not going to work because it might behave in a way that you don't expect. So if we hit this, you'll see that all that's happened is that the first letter that we typed has disappeared, because this scroll display left doesn't actually automatically keep scrolling it left. It just scrolls it one character to the left. So what's happening is that you're printing it on the screen, and then instantly, before you can even see it, you're scrolling it one letter left and then waiting for 2 seconds. So you don't actually have any time where you see the original message before you scroll that one letter. So there are two problems there. Let's fix the first problem. The first problem is that we want a bit of time before it starts scrolling. Okay, so before we start scrolling, we will say delay, maybe half a second or so. And this is really common with scrolling messages. The message comes up and it doesn't scroll immediately. You have a tiny bit of time before it starts scrolling, because you'll read a little bit of it, and then as you get to the end of it, it will start scrolling and you can read it. So delay 500 milliseconds. You might like to make that longer if you wish. And then we need to actually have a loop here where we get it to wait a tiny bit of time, scroll left one character, wait a bit of time again, scroll left one character, etc. So we actually need to make a loop that loops through all of the letters scrolling left. And how we're going to do that is we're going to make a little variable that keeps track of how far we've scrolled, and it's going to be an integer. We often use the letter I for index, but you could call it cursor or something like that. I'm just going to call it I. I think it's a little bit easier. So I'm going to say int I equals 0, and then I'm going to make a while loop, and I'm going to say while I is less than 30, so we're going to scroll it 30 characters across. We'll see if that works. We might have to change it a little bit later. Let's tab that in. So while I is less than 30, we want to we want to scroll the display left by one character, wait a very short amount of time, maybe 200 milliseconds, or maybe we'll do we'll have 100 milliseconds, so 10 times a second it scrolls. I think that's probably better than my original one was probably too slow. You'll have drivers waiting to try and read it and they'll be crashing and then they can't buy your product, right? So we'll go with that. And then what we're going to do is we're going to add 1 onto I. So what happens is that every time we go through this loop, the value of I goes up, and then when it finally reaches 30, then this while loop will end, if that makes sense. If we don't put this line here, it will enter into an infinite loop, which is not what we want, okay? Now this may or may not work. We'll give it a go. Start simulation. There, okay, I think actually that it didn't have enough of an initial. I would actually say maybe we leave it on for 2 seconds at the start, so you get a chance to actually start reading it, and then off it goes. Yep, and scrolling at 30 times was enough to go through our whole message. Just make sure that is the case with your message. You might need a higher number. Okay, so I hope that sort of makes sense, how we're manually scrolling through a certain number of times there. And once you've got that working, next I will show you how to display multiple rotating messages, and we will actually take this code out and make our own function out of it. All right, so this is a lot of code for one message, and if I wanted to make another message, instead of copying and pasting that code over and over again, that would cause some problems. It would, number one, take up a lot of space, and number two, if I wanted to change it in some way, I'd have to go through and change all of the ones that I'd copied and pasted. So what we can do is we can make our own function. So I can say Control X, get rid of that, and make our own function. Now in C++, the way we make a function that doesn't give us back anything, it just does something, it writes something on the screen. So we say void, that means it doesn't give us anything back. And we need a name for our function. So I'm going to call it display add. And this display add is going to be handed a string, and I'm just going to call it text. And what that means is that when we call this function, we can hand it a string and it will be saved into the variable text and we can use it here. So if we then paste all of this stuff, and then the only thing we're going to change is we're going to just say print text like that. Okay, so instead of printing the hard-coded string that we had before, it's going to print this string that's called text in there. Now inside here we can use or call the function that we've just created, and we can say display add, and we have to give it a string. And so this first one, I'm going to say, this is my first funny message. Oops. Obviously, you're going to have a much more interesting message than that. And then I'm going to say, this is my second funny message, etc., etc., etc. Okay, let's run that and see if it works. So this is my first funny message. This is my second funny message, etc. Okay. Okay, so I just paused it to set up something else that I wanted to show you. One way that we could improve this. As you can see here, I've got running the function that we've created twice here. The first one is going to be a very short message. The second one's going to be a really, really, really long message. And our current one will scroll 30 times, which will be too many for the first one and not enough for the second one. And I'll show you what I mean. So if I run the simulation, the first one starts scrolling and it continues scrolling even though there's nothing there. And then the second one will cut off before it's scrolled off the screen. Okay. So what would be ideal is if we could actually scroll it instead of a set number like 30, we could actually scroll it the exact number of times that there are characters in a string. Now in C++ you can get the length of a string by typing in the name of the variable, text, and say dot length and open and close brackets. Now I'll just explain this a tiny bit. Text is a special type of variable called a string. String has certain things that it can do, certain functions that it can do itself. And if you put a string dot, sorry, not that, if you put text dot, sorry, then you can put some the name of the function you want the text to do itself for you. And length here, what happens is it's a function, so it's got open and close brackets, and the text will actually get the length of itself and return it back to you. So this function will run, and let's say it was 57 characters. This then would be replaced by 57, and then it would say if I is less than 57. Okay, so hopefully that sort of makes a bit of sense. If it doesn't, please don't worry. But if we click the start simulation there, you can see now that the short message should finish the moment it goes off the screen, and the long message, the same thing. It should repeat through the exact same number of times, etc. Okay, and then obviously once it's done both of those, this loop will loop back up to the top and start again. Okay, I hope that you can now go and be a little bit creative. You might like to try and create this in real life as well, although it's a little bit challenging. You might like to add something else on here. Could you add an LCD light that flashes every time a new message comes up, just to distract the drivers a little bit more? See if you can do something to make it your own, and I can't wait to see your finished projects.